most recently, in 2019, a very important work that we'll discuss a little bit today, showing that these microbes are actually pretty tied to exercise performance. Everyone knows about, when you're exercising. I'm going to put this in very simplistic terms. There's debate over this between lactic acid and lactate, but basically, for the layman, when we're working out, part of the burning feeling we get is, attributed to change in pH in the muscle tissue, lactate. What we found in this work in 2019 was lactate can actually cross over from the circulation while you're exercising. These individuals were running a marathon, go into the gut, and there's a specific microbe that actually feeds on lactate, and it biotransforms it into propionate, which is a short-chain fatty acid, which then goes back into circulation and is used as a fuel source for the host. So it can actually contribute to exercise performance. So here we see one of these really initial ways that the microbiome is associated with our muscle tissue and exercise. Now, considering the main functions of the gut, and I put a few bullet points here to really show you just how tremendous this potential is, from harvesting food energy, synthesizing different types of vitamins, even hormones, boosting our immune system, even affecting things like our blood lipids, our blood glucose. When you go to your doctor, these are very important markers that they'll look at your metabolic health. We know that the gut interacts with all of these. Now, here at Arizona State University, where I did my PhD, we looked at college-aged individuals, obviously, because of proximity to that population being at the university, looking at sedentary individuals, looking at their microbiome versus athletes. We found that the athletes just had a much more diverse gut microbiome. And not only that, their microbiome was very stable, meaning it didn't shift much over time. And kind of conceptualizing, what this looks like, and kind of bringing in the idea of, an ecological view of all this. Athletes just seem to have a more resilient gut microbiota, and we can kind of think about this like these mounds that I have. So you have the sedentary person seated in the chair there. They have, if you can think about their microbiome as this kind of ball figure, kind of precariously sitting on this mound. If I wanted to shift the state of that microbiome, it could be pretty easy to do for this, in this particular very simplified scenario. It could be perhaps dietary. It could be maybe an environmental exposure. It could even be medication. It could be a dose of antibiotics. But whatever it is, this individual, or in this schematic, we don't have high levels of stability. We don't have high levels of resilience, because there's a tipping point we can see where once that microbiome or that ball shifts, it's not going to return to that state, versus an athlete who, through years of training, of having a different type of diet, has really kind of built this deep valley where it would be very hard to shift their microbiome. So, of course, the question is, how is this type of resilience built? And just as we think about training our muscle tissue, or say you're an endurance athlete, you're thinking about lactate threshold, you're thinking about pulling in oxygen. So you're still training your physiology. Can we actually train the gut? And this likely has a lot of transference over into other populations who aren't necessarily trying to be athletes, but they're just trying to be healthier and get a healthier gut. So we this concept we call hormesis, which is a form of stress, or eustress, meaning a beneficial stress over time. And most commonly, when we think about what's occurring in the gut during a really intense bout of exercise, particularly someone that's naive to exercise, hasn't really done very much of it, one of the most common things that we'll report is stomach aches, stomach pain, diarrhea is very common. This can be for a lot of people that were starting, marathon training, for instance. So what's actually happening to these individuals is because they haven't trained that tissue. So we're talking about the brush border, which is the cells that line the lumen of the gastrointestinal tract. What can actually happen is blood is pulled away during exercise, right? It's going to the muscle tissue to help with work, and a hypoxic state occurs. So a lack of oxygen to this tissue can cause damage to this tissue, and we can get degradation of things like tight junction proteins, which hold together those cells, and we can get influx of various problematic particles from the gut, namely endotoxin, which is a potent stimulator of the immune system and could cause inflammation. So we get an inflammatory state, we can get gut injury. This is not good, right? So based solely on that acute event, we would say, well, maybe exercise isn't really good for our gut. But what we know pretty well, actually, and a lot of this research was done decades ago, even back in the 80s and the 90s, over time, these tight junction proteins are able to come and reinforce the brush border, make it stronger, and we don't get an influx of these particles, and we don't get inflammation. So here we're seeing we're actually training the gut. We're having an adaptation occur in this tissue. Now, what are some of these stressors? And I'm going to use running as an example because it's pretty simplistic if you think about, say I go out, I live in Phoenix, out here in the southwest of the US, so it gets pretty hot, right? Now, if I go out and run during the summer, not advisable, but there's obviously a very high environmental temperature here. My internal body heat is going to go up. That is a stress that actually we know affects our cells, and of course, it affects the microbes that are residing in our gut. Hydration is another very important factor in relation to exercise. We know that there's a lot of fluid flux. Now, if you're running, you're going to be pulling, different fluid, particularly like blood here I have as an example, away from the gut to your working muscles. And there's also other factors that are causing some issues here, like just the physical act of ground reaction force running over the ground. All these things, we know that they affect the body, but we're not really fully understanding how they affect the microbes that reside in our gut. Now, I'm going to share some research showing this connection. What really we kind of think of when we talk about the gut-muscle axis is this two-way street, so to speak, where the microbiome can produce various metabolites that can cross over into the host, and the host can affect the gut microbiome. So we see this kind of reciprocal relationship. Now, there's other factors, like I was just discussing. There might be, say, dietary factors. There might be, if you're running outside and there's bad air quality, pollution's an issue. Those we won't really talk about, but they obviously can affect this relationship. More generally, diet can be actually a stress. Every time we're eating, it's actually a metabolic stress in our own physiology. And if we're having food come in, that can be a stress to the microbes because there's going to be competition for the type of substrate that's available. Another really important emerging stress is fasting. So we know that fasting can actually be beneficial counterintuitively to the gut microbiome, because normally when someone thinks about the turnover of these microbes, how long they live, basically, you think, well, it's probably good to have them constantly fed. Doesn't seem like that's actually always the case. We'll actually save that, I think, for another future talk that I have done work in. I think I can have some really interesting discussion around that.